Hi, my name is Patrick Reagan. This series of videos, Computer Electricity and Electronics, will explain what is electricity and how it affects the computer and various electronic components that are heavily used in computers. This video is called Using a Multimeter. With computers, you can use a multimeter to test connectivity of a wire, test connectivity of an ESD strap, and test the voltage output of the wall outlet, batteries, and power supply. While this is not as cool as some of the other videos, this little skill can help you troubleshoot computer problems that are related to power problems and to test wire connectivity. This video will also help reinforce how conductors and insulators relate to voltage and resistance. A multimeter is a measurement tool used in electronics. It combines a voltmeter that measures voltage, an ohmmeter that measures resistance, and an ohm meter that measures current. When working with computers, you can use the multimeter to verify the correct AC voltage is coming from the wall socket, verify the correct DC voltage is coming from a battery or power supply, verify wire connectivity, and measure resistance. When troubleshooting computer problems, you would not typically use an ohmmeter. Here are two examples of a multimeter. The one on the left has a dial which is divided into three sections. DC voltage measurements are measured with the white settings as indicated by the V with the straight line above the three dots, while the AC voltage measures are measured with the white settings as indicated by the V with the squiggly line. The green values toward the bottom of the dial has the omega or ohm symbol, which is used to measure resistance. The green values on the right are used to measure current as indicated by the A. The Fluke multimeter has a more simplified dial, but uses similar symbols to indicate AC voltage, DC voltage, resistance, and current. When you decide to use any of these settings, you should have an idea on what kind of measurements you expect. For example, if I am measuring voltage coming from the wall in the United States, I would expect 120 volts. Therefore, I would use the 200 AC voltage value on the one on the left. You want to select a value larger than the one you expect. So 200 AC voltage is the next largest value above 120 volts. If I was measuring voltage in Europe, where I expected a 240 volts AC, I would select 600 volts. If you don't know what the voltage to expect, always go to the largest setting and dial it down as needed. For the Fluke model on the right, I would just select AC voltage since it will auto-detect the voltage. If I was measuring the voltage from a power supply, I would not expect more than 12 volts. Therefore, I would use the 20 volts DC on the left and DC voltage on the right. When measuring voltage or resistance, you're going to use the wires connected to the same jacks. While the colors technically don't matter, you should use the black cable plugged into the COM port and the red cable connected to the V omega connector. If I was measuring current, which is a little bit more complicated, you would connect the red wire to the 10 ADC port. When measuring when the two contacts are touching, you would expect good connectivity, which shows 0 ohms. However, when you have the two contacts apart, separated only by air, you do not have good connectivity. Therefore, you measure extremely high resistance. When measuring a resistance of a copper wire, which is a good conductor, you measure 0 ohms. And if we take this a step further, when I'm measuring a copper wire that is part of a 6-foot power cable, I also measure 0 ohms. When I measure the resistance of rubber, which is a good insulator, it measures extremely high resistance. Remember that an ESD strap should have a resistor to help protect you from accidental shock. To test the connectivity of an ESD wrist strap, I measure 1.004 megaohms. This shows that the two ends are connected with the 1 megaohm resistor. Next, we're going to test an AC outlet. The voltage between the hot and neutral should be 110 to 125 volts. The voltage between the hot and ground should also be 110 to 125 volts. Keep in mind when looking at the numbers in the diagram is upside down when compared to the outlet in the picture. In the picture, the hot wire is on the right and the neutral wire is on the left. When testing between neutral and ground, you should measure less than 0.5 volts. Using an AC outlet tester on the same jack, it also shows that the AC outlet is wired correctly. Here, I have a different outlet that shows that it has an open ground. So when using the multimeter on this outlet, the voltage between the hot and neutral is correct. But the test between ground and neutral is too high. Testing a 9-volt battery is simple, where you would expect it to measure 9 volts. You can also test output from a power supply. The older Molex cables used with the SATA drives is easy to test with a multimeter. Since the red wire is plus 5 volts and the black wire is ground, you should measure plus 5 volts. Similarly, yellow is 12 volts, which should allow you to measure 12 volts when using the yellow and black wires. You can also do similar measures with power supply that goes to the motherboard. Question: when testing an AC outlet, which of the following will measure 0 volts AC? Choose two answers. Answer: neutral and ground. Question: what voltage does the power outlet provide in the United States? Answer: 120 volts AC. For more information about using multimeters, visit the sites listed here. In summary, a multimeter is a measurement tool used in electronics. It combines a voltmeter that measures voltage, an ohm meter that measures resistance, and an ohm meter that measures current. It is plus 5 volts between black and red wire. AC outlet in the United States should measure between 110 and 125 volts. Thank you for watching this video. The next video will be power fluctuations. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.